All right, Algebra 1 students, let's move on. I'm going to introduce the other activity, and then I'm going to jump to the end, to the synthesis. Okay? So in this activity, this is an extension. So in 14.2, you got to experiment with what happened when you added certain pairs of equations together. And you got to do that visually with two mobile balance puzzles. Okay? So now we're going to take the same three systems that you saw earlier. Okay? And you're going to use graphing technology. I suggest that you just go to Desmos, that you open up another tab and you open up the graphing calculator in Desmos. That's what I suggest you do, rather than use the tools that are embedded in the student task statements, and that you just then go back to the student task statements and answer the questions. Okay? So I'm not going to do this for you. I want you to do it for yourself. And then we're going to talk about it later. So you're going to use graphing technology. You're going to find the coordinates of the system. Then you're going to find the sum or difference of the two original equations. And then you're going to graph the third equation on the same coordinate plane. Okay? So first you're going to graph the first two equations. Okay? Then you're going to identify the coordinates of them. Then you're going to add these two together. Okay? I will walk you through the first one. Let's do this. Okay? So let's go to Desmos. Open up the graphing calculator. So you're going to type 4x plus 3y equals 10. Okay, there's one line. And then you're going to type negative 4x plus 5y equals 6. Okay, you're going to identify this point, 1, 2. All right, so now you're going to add these two together. Okay, and when you do that, you're going to get rid of the x's and you're just going to have y's. You're going to have 8y equals 16. Okay, so we're going to now type that equation. And what do you notice? What happens? Okay, what does that third equation do? That third equation equals one of your coordinates, the y coordinate. Okay? And so now that I've done this for you, you are going to do the same thing for the other two systems. And I'll meet you at the end. Okay, so it's important for you guys to understand that this synthesis part in the lesson is not often covered in the student task statements. I do not suggest that you do the Are You Ready for More unless you are a really strong student who wants a challenge. Okay, that's what this Are You Ready for More, that's who it is geared to. So I don't know whether I made that clear. You might notice that in class, I almost always, if not always, skip it. So I don't care if you do this part or not. Okay? And you can see that it's not really covered in the, we just gloss through it. So before we go to this is the summary that is just going to tell you all of the things that they covered in the lesson. It's the summary of the lesson. But this is a very important part of the lesson right here. Is they're asking you to think about, here are 3 of the systems that I believe you saw in a previous lesson that you might have solved by substitution. Okay, here's one that you could have easily moved the M term over and then dropped this into here. But look what you could do now. You could solve this one by elimination, couldn't you? Here's one that you couldn't just add the 2 together. You could rearrange it so that if you rearranged it by moving the X term over here, could you add them together, or would you still use substitution? Okay, so think about that. And then lastly, look at this third system and say, what would happen if I added these 2 together? Could I solve it? Or should I go for substitution, where I could isolate the 5x and take this, what I would have left, 22 minus 11y, and just drop it in place of the 5x. Okay? And likewise, this one, I could drop this in front of, instead of y. Or would it be possible for me to solve this system by elimination? And if I could solve it by elimination, which would I rather do? Okay, and you get to think about that. I know what I would say, but I want to hear what you would say. Okay? And like I said, here is on the student task statements. They do the same thing in a slightly different way. They just give you the information. They define it, what elimination is. They point out to you that one equation has a positive 7y, the other has a negative 7y. And if you added them together, you would cancel one of your variables out pretty quickly. And then you could solve for 1. Okay? Then you would take that and substitute it back in for the other variable. Okay? And now you have your solution to the system. Okay? And what if the equations don't have opposite coefficients? What if they're not the opposite? They're stretching this a little bit. They're saying that instead of adding, we subtract. Okay, and remember, when you subtract, you have to change the sign of all 3 of these. Okay, so that means this term becomes negative 8r, this term becomes negative s, and this term becomes positive 3. Okay, so you're able to do it. Okay, and then you're able to take that number that you got for s, drop it into the equation, and solve for r. Okay? And so they go back to the original activity that you did, the first activity, where you graph the system and then you added the two equations together, and you notice that you get either a horizontal or a vertical line that goes through the same solution point. Okay? In future lessons, we will investigate why this strategy works. Okay? Thank you so much for listening to this, young people. I hope this helps you get through this lesson, and I'll see you sooner than later, definitely in the next video.